So let me know
No, sir.
if you are facing the problem. Then we will go with some more examples. काय अडचण आहे का कोणाला काय? So be frank, please, in this part. Are you expecting the more examples to be solved, or the examples which I have solved is sufficient?
Sufficient, sir.
Sufficient, na? Anybody? Any else? Anybody else other?
Sufficient आहेत सर.
आहेत ना? मग बाकी काय अडचण नाही ना आता असाइनमेंट वगैरे सॉल्व करायला?
नाही सर.
Sir, last question. Twiddle factors आहेत ते.
Twiddle factor, okay, you just leave that part. I will cover that in the 4th unit. There we will solve it.
Okay, sir.
Anything else?
No, sir.
Okay. So then, can I consider that there is no problem so that I can go to the next unit? And maybe
Yes,
within 2-3 days, I'm going to take you one test based on this unit 2 and unit 1. Right? So let's see like how it can be planned. And what I'm expecting is you have to solve assignment questions of all question set, right? Set A, set B, and set C. So with that you can make your more examples to be solved, and you will get more practice on that part. Okay?
Okay, sir.
Okay. So now let us move towards the next chapter. That is again a very simple and very small chapter. It is just a part of the second unit only. तो syllabus में थोड़ा change किया है उसको. So let's have a discussion on that. So today you just note down the syllabus. Syllabus for unit 3. Just write the title as unit 3. Just note down this title. Linear filtering method based on DFT. Linear filtering method based on DFT. So this is what your title of unit 3. Or?
Yes, sir.
Now let's load down the syllabus. And also you just note down the textbooks. So the syllabus is again here. Use of DFT in linear filtering. Use of DFT in linear filtering, comma. Filtering of long data sequences. Filtering of long data sequences such as overlap save and overlap add method. Filtering of long data sequences such as overlap save and overlap add method. And last one is frequency analysis of signals using DFT. Frequency analysis of signals using DFT. It is of 5 hours again. Just note down the textbooks also. The textbook and reference book. And one more thing, what I want to mention here is, so I am expecting that like everyone is writing properly in notebook. Okay. Yes or no?
Yes, sir.
Hope your all notebooks are complete. So one more thing, what I will do is, so batch wise, I will divide it like in 3 batch. Roll number 1 to 20. Are you just make a note of this point? Roll number 1 to 20 will scan the chapter wise, like chapter 1 notes as well as chapter 2 notes, and send it on my mail by saving with your roll number. Can you do that part?
Yes sir.
कर सकते हैं ये? Any problem with this?
Yes, sir. No, sir.
So tomorrow 1 to 20 will send me the notes, and day after tomorrow 21 to 40, and after that again remaining students. You please send it on mail, not with the WhatsApp group. Mail karo such that I will also have some record with me ki what are all the things we have covered and how we people are noting that we will do on that part. Okay? So any problem with this?
No, sir.
Okay. So by tomorrow 1 to 20 will send me the notes on mail. Hope everyone knows my mail. मेल आईडी पता है
Yes, sir.
सबको msmatpati@coe.sweri.ac.in मेल करना है and name the topic with your roll number and name so that I can identify it easily, and it should be in PDF format, not in an image format again. Okay, now have you noted this?
Yes, sir.
Now, as already we have discussed in the second chapter, like how to perform a circular convolution using DFT and IDFT method. That part we are repeating over here again, like how this DFT can be used as a for a linear filtering purpose. Okay, and as we all know that normal convolution, like linear convolution, is used for filtering operation, we wherein we cannot use this circular convolution for the filtering operation because circular convolution results are correlated results, मतलब allied results मिल रहे हैं वहां पे. Have you remember this point? Linear convolution का जो result है without aliasing रहेगा, and the circular convolution result is allied result आ रहा है वहां पे क्योंकि some points are overlapping with the other values. So for that purpose, for filtering operation, we are using linear convolution, not a circular convolution. Can you remember this point?
Yes, sir.
Now, the second point is like filtering of long data sequences such as overlap save and overlap add method. So these are the second like filtering of long data sequence means suppose if we have an input sequence of like a 15 point or 20 point, then is it possible to go with like linear convolution or circular convolution? कर सकते क्या वहां पे directly? So if it is a 15 point input sequence like x0 to s15, right? So then is it possible directly to process those samples through the DSP long sequence? It is very difficult to process through the DSP because it requires the maximum memory size और processing time आपका बढ़ जाता है यहाँ पे. So for that purpose, what we are doing is we are just making that long duration sequence into the smaller blocks of length like 5, 6 as per the requirement, and we are processing those blocks one by one, and at the other side we are just adding those blocks and we are getting the result. So this is what the process we are following in this filtering of long data sequence, and there are basically two types like overlap save and overlap add method. Okay, so then so here if you look at into the part, so that is let us study one by one. So use of DFT in linear filtering. So if we have a sequence called as x of n and h of n, so how we are writing the formula for linear convolution? The formula for linear convolution, if we have a two finite sequences, क्योंकि इनफाइनाइट सीक्वेंस आप हमें पता है कि लीनियर कन्वोल्यूशन का फॉर्मूला इनफाइनाइट है लाइक k equals to minus infinity infinity, but an infinite sequence cannot be analyzed in a DSP system. So for that we are considering here the two, we just write one point here, we just write a title as use of DFT in linear filtering. We just write a title as use of DFT in linear filtering. Return the title.
Yes, sir.
So after that you just write, let us consider x of n and h of n let us consider x of n and h of n of finite duration length of finite duration length, then second point you write this, then a second point you just write a sequence x of n of length L, a sequence x of n of length L filtered by an FIR filter, filtered by an FIR filter with impulse response, filtered by an FIR filter with impulse response h of n of length m, h of n of length m. Then according to the formula of linear convolution, according to the formula of linear convolution, we can write as just note down that y of n equals to k equals to 0 to m minus 1, y of n equals to k equals to 0 to m minus 1, h of n x of n minus k, h of n multiplied with x of n minus k. So this is the formula of linear convolution again. Any confusion here?
No, sir.
It is already we have discussed. Nothing new is there part again. So the length of y of n, as already I told you that, what is that? It is L plus m minus 1. The length of y of n is like the length of the linear convolution. Output length of the linear convolution is like L plus m minus 1. So here he has taken a reference of one example, how this can be used here. So that is, you just note down that example x of n equals to, we have a sequence 1 1 1 comma h of n equals to minus 1 and 1. So what are the different types of linear convolution? Can anyone tell me? What are the different types of linear convolution? Yes, anybody please?
Graphical,
Tabular.
and multiplication.
Graphical, tabular and multiplication directly. Very good. So now here what he has done is, it is like the graphical बोल सकते हैं हम, नहीं तो ये like graphically what are, how do we write for graphical method? So what he has written is, first he has written the x of n and h of n, right? So he has, it's like it should be h of minus n, not h of n. Just make that correction. तो पहला हमने x of n as it is लिखे 1 1 1. Then second point what he has written is, he has written it as h of minus n, you just write. तो h of minus n के लिए क्या लिखा है उसने अभी? So let me take it on the board. Okay. So what he has written is, so x of n he has written. What is x of n? X of n is equals to, is 1 1 1. Then h of n equals to, we have taken it as minus 1 and 1. Okay. So now, so he has solved this example this way. So first, let us take x of n is equals to, we have this block, right? 1 1, ये आपको समझने के लिए आसान भी हो जाएगा. 1 1 1. देन he has written h of minus n. तो क्या कर रहे हैं हम ग्राफिकल फॉर्म में? What we are writing in graphical form? Anybody?
Folding.
Folding of a sequence we are doing. अगर इसका h of minus n लिखूंगा मैं तो what will happen? So here -1 और 1, ये आपका 0th पॉइंट है यहाँ पे, और यहाँ पे इसका 0th पॉइंट ये है. ठीक है. सो नाउ इफ यू लुक एट इनटू दिस पार्ट, सो हियर दिस इज द 0th पॉइंट. तो यहाँ पे आपका 0th पॉइंट है और ये यहाँ पे आपका 0th पॉइंट है. नाउ लेट अस टेक y ऑफ 0. y ऑफ 0 का वैल्यू क्या आएगा अभी? व्हाट इज y ऑफ 0? सॉरी, दिस फर्स्ट पार्ट इज, यहाँ पे x का दिस विल बी लाइक, इट विल बी रिटन लाइक दिस. So where is the 0 for the first part? So here we'll write it like this. So ये it is like so now here the 0 for this is here, and so this point I'm going to write it like this. So where I will write for this is again, okay, so this is the table I'm going to draw. So I am folding that part. So it is -1 and 1. Now if I want to write y of 0, so what is the answer? Answer क्या आएगा y of 0 का? Anybody?
-1.
-1.
Yes, it is -1. क्योंकि so this point is multiplied with, so this is multiplied with this, right? So this is multiplied with this, so value will be, it is -1. Getting? This is like the graphical representation हम जैसा कर रहे हैं वैसा. So any confusion here?
No, sir.
Next what we are doing is like इसको शिफ्ट करते जा रहे हैं हम. So likewise he has explained here nicely. So hope you have understood the diagram. So यहाँ पे what he has written is, he has written as the value of x of n. तो ये वैल्यू आपका x of n का है 1 1 1, right? Then it is h of minus n, you just make it is. So it is h of minus n is 1 minus 1. So y of 0 is -1. Clear? Then what is the second step he is writing? अब पहला as it is लिखे है, right? x of n I am writing as it is, and what I am doing this, कोई बताएंगे मुझे यहाँ पे? What is this? This is like our h of क्या पार्ट है? Anybody?
1 minus n.
Yes, it is shifting on the right side. So h of 1 minus n it is. Understood? Have you understood this part? Second one. Any
Yes, sir.
confusion here? Now, what he has
No,
done
sir.
is he has just taken the product of this. So this way also you can go. This is if you are understanding easily, right? So -1 into -1. क्या हुआ आंसर आपका? -1. Then next 1 into 1. So +1. What will be the value? The value goes to what? It is 0.
0.
Right? So y of 1 answer is 0. Getting this point? Any
Yes.
confusion here? Now
No.
No, sir.
x of n और as it is लिखे यहाँ पे. Then what he has done next part? So it is h of क्या किए? 2 minus
2
n.
minus n.
Right? तो हम इसको और एक बार शिफ्ट कर रहे हैं. Right? So it is h of 2 minus n. Then we will get the value of y of 2 as 1 into 1. Again it is 1. So 1 into -1. Again it is -1. So will be equals to, the value goes to 0. Right? Then third one similarly again. So x of n left kept it as it is, and again it is shifted to one more value, so it is h of 3 minus n, और आंसर आएगा आपका y of 3 का 1. So this is how we are simply performing our linear convolution. Understood?
Yes, sir.
Yes, sir.
Any difficulty here?
No, sir.
Now what is our final answer? You just note down the final answer as y of 0 equals to what is that? In bracket you write minus 1 0 0 1, minus 1 0 0 1. ये अपना नॉर्मल लीनियर कन्वोल्यूशन है. ठीक है. Now can I move to the next part?
Yes, sir.
So this is the alternate for our graphical representation. आपको अगर ये आसान लगता है तो ये भी कर सकते हैं आप, right? Then next is, we just write now in the frequency domain. You just write in the frequency domain, y of omega equals to h of omega into x of omega. Y of omega equals to h of omega into x of omega. Then next point, sampling both sides by an interval. Sampling both sides by an interval 2 pi by n. So can anyone tell me why we have to go for the sampling here? So this part already I have covered. Nothing new I am telling you. Just within with different proper notations we are just writing it. क्यों sampling कर रहे हैं यहाँ पे? Can anyone tell me? What is omega here? Omega is what?
2 pi by n.
No. Like what is the term it is? Whether it is continuous in nature or discrete in nature. Yes, anybody? Frequency domain sampling and its reconstruction we have studied already. DFT ka first point. Right? So there what we have done is, as omega is a continuous function, that is like a radian frequency, omega is in radian frequency and it is a continuous frequency. So we cannot process this with the DSP. So for that purpose, we are sampling this function with the value of 2 pi by n into k. येतं का लक्षात काय?
हाँ, sir.
Right? So that's what I am doing here again simply. We are converting that continuous time function to a discrete function. So that is, we are going for this sampling function. Now, just write that the kth sample is given by, just replace that omega by the value 2 pi by n into k. Two pi by n into k equals to h of 2 pi by n into k, then x of 2 pi by n into k. Next point, using the DFT notation. So first part we are writing it as simply y of k equals to h of k into x of k. Y of k equals to h of k into x of k. Where x of k and h of k are, the DFT, where x of k and h of k are the DFT with zero padding, of x of n and h of n of x of n and h of n respectively. Of x of n and h of n respectively. So any confusion here?
No, sir.
Are you finding any new term? Can I move to the next part?
Yes, sir.
Yes, sir.
Now, next point, performing the inverse DFT. It is like the process what we have done for calculating a circular convolution with DFT and IDFT method, right? Next point you write, performing the inverse DFT. Performing the inverse DFT. That is what we can write, y of n equals to, we will write it as IDFT of y of k. Y of n equals to, we will write it as IDFT of y of k. The next point you write, is a y cap of n the same as, is a y cap of n is the same as y of n, y of n. The answer is yes. Answer is yes, because y of omega is the Fourier transform of y of n, because y of omega is the Fourier transform of y of n. To recover y of n, to recover y of n, to recover y of n, an n-point sampling of y of omega, to recover y of n, an n-point sampling of y of omega, and an n-point IDFT is necessary. An endpoint IDFT is necessary. So let's have one more question. Just write that point. An equivalent question is, under what condition, circular convolution becomes linear convolution? Under what condition circular convolution becomes linear convolution? कोई बताएंगे मुझे आंसर इसका? Can anyone tell me under what condition circular convolution becomes linear convolution? This already we have discussed. Yes, anybody? Or should I take the names only? Gayatri is there. Gayatri Kuntala.
Yes,
Hello?
sir.
हाँ मैडम,
Yes, sir.
आप बता सकते हैं मुझे आंसर उसका? Under what condition circular convolution can be called as linear convolution? Yes. पता है क्या नहीं मैडम?
नहीं sir.
Okay.
नहीं.
Are you present for the last lectures?
Yes sir, but due to lot of network problem म्हणजे जरा लेफ्ट होत मधनं.
मग मला कुठं सांगितलं मॅडम तुम्ही? You have faced these problems. Have you informed me? and you have not asked me any question on
नाही
that
मी
part also.
सीसीना सांगितलं होतं.
हा
सीसीना सांगितलं होतं मी.
नाही मग आता जर कळालं नसेल तर तुम्ही मला पर्सनली मेसेज करायचं, सर मला हा टॉपिक कळाला नाही, तर तुम्ही त्याच्या नोट्स तरी पाठवा किंवा काहीतरी एक पीपीटी तरी पाठवा, विचारायला पाहिजे ना.
ठीक आहे सर.
नेक्स्ट गायत्री कदम इज देयर.
येस सर.
हाँ मैडम, कैन यू टेल मी दिस आंसर?
नो सर.
तो फिर सबको अभी लाइक हर्षदा,
यस सर.
आप बताएंगे मुझे आंसर मैडम?
नहीं सर.
वेरी गुड. तो फिर अभी आई डोंट नो व्हाट टू से ऑन दैट पार्ट, सो लेट अस गो बैक अगेन. तो रिसेंटली हम 2-3 दिन पहले, राइट, सो वी हैव डिस्कस्ड हाउ टू कैलकुलेट सर्कुलेशन का सर्कुलर पहला लीनियर कन्वोल्यूशन वी हैव सॉल्व, बराबर हर्षदा?
हाँ सर.
लीनियर कन्वोल्यूशन का एग्जांपल सॉल्व किए हमने, राइट,
हाँ सर.
ग्राफिकल मेथड
हाँ.
से सॉल्व किए. उसका
यस
रिजल्ट
सर.
हमें सर्कुलर कन्वोल्यूशन के साथ करना था. सर्कुलर कन्वोल्यूशन विथ जीरो पैडिंग वी हैव स्टडीड. केलंय का नाही?
यस सर.
वी हैव स्टडीड सर्कुलर कन्वोल्यूशन विथ जीरो पैडिंग. तो वहां पे क्या आंसर आ रहा है आपका? We have studied all these things already, like how to convert circular convolution using linear convolution or linear convolution using circular convolution. Yes or no?
यस सर.
Right. तो अभी यहाँ पे कंफ्यूज मत कर लो आप लोग. So just I have asked it in a different way. So let me take this as again. So what is asked here? What condition सर्कुलर कन्वोल्यूशन बिकम्स लीनियर कन्वोल्यूशन? अभी हमने लीनियर कन्वोल्यूशन का रिजल्ट कैलकुलेट किए. इट इज गिवन x ऑफ n इक्वल्स टू 1 1 1 एंड h ऑफ n इक्वल्स टू -1 आणि 1, बराबर?
यस सर.
ओके. सो इफ आई वांट टू गेट द सेम रिजल्ट ऑफ दैट लीनियर कन्वोल्यूशन यूजिंग सर्कुलर कन्वोल्यूशन, तो क्या मॉडिफिकेशन करना पड़ेगा मुझे? What modification I need to do?
लो पैडिंग.
Huh? Yes, you are right. Tell me once again it is.
पैडिंग
पैडिंग ऑफ जीरो करना है. अपना आउटपुट लेंथ में कितने सैंपल्स आ गए? वहां पे 4 सैंपल आ गए. तो सर्कुलर कन्वोल्यूशन के लिए क्या करना है हमें? We need to make a length of the sequence equals to, इक्वल करना है. वहां पे कितना इक्वल करना है आपको? जो आपका लीनियर कन्वोल्यूशन का रिजल्ट आया हुआ है. तो लीनियर कन्वोल्यूशन रिजल्ट इज ऑफ 4 सैंपल्स. सो आई नीड टू मेक the circular convolution. To perform a circular convolution, the length of sequence should be of 4 samples. ठीक है, बराबर?
यस सर.
So
हाँ.
गायत्री, स्क्वायर आणि हर्षदा,
यस सर.
इज दैट क्लियर नाउ?
यस सर.
Yes, sir.
समझ में आया. यस सर.
मग काय नवीन सांगतोय का? मग काय तर
येस सर.
जुना शिकलेलाच ऑलरेडी आपला, राइट? Nothing new I am teaching today, just in a different way I am just arranging it. Then last point you just note down, a 4-point circular convolution. We are performing that, a 4-point circular convolution of the previous example in the following slide. तो आप जो एग्जाम्पल हमने लीनियर कन्वोल्यूशन किया अभी, उसका 4-point सर्कुलर कन्वोल्यूशन करेंगे आप लोग. कैन यू डू दैट एग्जाम्पल?
यस सर.
Just do it. Let me give you 1 or 2 minute time. Just do that example as a linear, like circular convolution. So please everyone do this. आणि तुम्हाला काय क्वेश्चन असलं तर प्लीज आस्क द क्वेश्चन्स. मी क्वेश्चन विचारल्यानंतर येत नाही सर म्हणण्यापेक्षा लाईक इफ यू आर आस्किंग द क्वेश्चन्स सो इट विल बी मोर हेल्पफुल फॉर यू पीपल. Is everyone doing that?
Yes, sir. Done.
I got the answer.
Yes, sir. Same answer.
Same
Minus
answer you are
1001.
Barabar. So this is how we can say that a circular convolution can be performed using a linear convolution by padding the zeros. Okay. So that means simply what we are writing? We are writing a matrix for this. H of n we are writing a matrix. तो मैट्रिक्स क्या लिख रहे हैं यहाँ पे? सो फर्स्ट आई एम राइटिंग -1 1 0 0 देन 0 -1 1 0 0 0 1 and 1 0 0 -1. If I multiply this with the value, what we can say? 1 1 1 0, then I will get the answer as y of n equals to, I will get it as, the answer we will get it as, it is, can you tell me the answer? -1 0 0 and 1. Barabar? Have you got this answer?
Yes, sir.
Yes, sir.
So any difficulty here now?
No, sir.
No, sir.
Okay, so then we'll go ahead again. तो यहाँ पे वही किया उसने, just write that this example shows that this exam, no need to write down that once again. तो मैट्रिक्स मेथड आपको अगर समझ में आ रहा है तो we will go with that part only. So this method shows that, example shows that by zero padding such that, by zero padding such that the length of the circular convolution is, by zero padding such that the length of the circular convolution is greater than or equal to, greater than or equal to L plus m minus 1, L plus m minus 1, comma, circular convolution is the same as, comma, circular convolution is the same as linear convolution. Circular convolution is the same as linear convolution. Any difficulty, any confusion here?
No, sir.
Okay.
Yes, sir.
Now, let's write this point. The multiplication in DFT domain, I'm just summarizing that now. The multiplication in DFT domain corresponds to, the multiplication in DFT domain corresponds to circular convolution in the time domain, circular convolution in the time domain. The next point, by zero padding the two sequences. This is summary we are just writing here. By zero padding the two sequences, by zero padding the two sequences. Circular convolution becomes linear convolution. Circular convolution becomes linear convolution. Next point, to perform linear convolution using the DFT, to perform linear convolution using the DFT, zero padding x of n and h of n, zero padding x of n and h of n, such that the length of them is n equals to L plus m minus 1. N equals to L plus m minus 1. Second point, calculate an endpoint DFT. Calculate an endpoint DFT for both the sequences. And multiply them point by point. And third one is perform an endpoint inverse DFT. So this is how we are using DFT as a linear filtering. Understood?
Yes, sir.
Now let us take one more example. For the same sequence, you just calculate the answer for a 3-point circular convolution. Just note down x of n and h of n, and we just calculate it for 3-point circular convolution and 5-point circular convolution. Have you noted the question? Just calculate it for 3-point circular convolution and 5-point circular convolution. Can you do that? Where x of n equals to, it is given as again x of n equals to, it is given this way, like h of n and this part, and we just do the circular convolution for 3-point value, and then just do the circular convolution for the 5-point value. First do it for 3-point value, then do it for the 5-point value. Ketki Deshpande is there? Ketki Deshpande.
Yes, sir.
हाँ, आप बताएंगे मैडम how we can solve this? Ketki Deshpande. Can you show me or can you tell me like how it can be solved?
By which method we can solve?
हाँ,
कॉन्सेंट्रिक सर्कल मेथड ने सॉल्व किया तो चलता है क्या?
चलेगा, कोई प्रॉब्लम नहीं है, बट यू गो विथ मैट्रिक्स मेथड, सिंपलेस्ट वे आई विल टेल यू. कॉन्सेंट्रिक आप कर सकते या मैट्रिक्स मेथड कर सकते हैं यहाँ पे, या डीएफटी आईडीएफटी भी कर सकते हैं, बट फॉर अंडरस्टैंडिंग नाउ जस्ट डू इट विथ द मैट्रिक्स मेथड. ठीक है?
ओके सर.
Yes, anybody has got the answer?
Yes, sir. 0, 0, 0.
All zeros?
Yes, sir.
Yes, sir. For 3 points.
For 3 point, it is all zeros. Okay. Let me check that answer. So 0, 0, 0. It is okay. Then do it for 5 point. Do it for 5 point. Komal Jadhav is there?
Yes, sir.
हाँ मैडम, किए क्या आंसर? Have you got the answer of previous example?
No, sir.
किए क्या नहीं किए मैडम? Any difficulty you are facing? Are you facing any difficulty? गायबच झाले का? कोमल,
Yes, sir.
आर यू फेसिंग एनी डिफिकल्टी? कळालं का काय करायचं नेमकं?
हो सर करते.
ओके. Nikita Bhosle is there? Nikita Bhosle. Hello. Hello. Nikita. Hello. Okay. Have you got the answer?
Yes, sir.
Yes, sir.
So what is the answer?
-1, 0, 0, 1, 0.
So -1 0 0 1 0. तो यहाँ पे क्या मीनिंग है इसका अभी? What the conclusion you can go out of this part? Right? So here I have given you 1 point. So here 1 point we have noted. यहाँ पे, right? So what we have written? The value should be this one. 0 padding and h of n such that the length of them is n equals to l plus m minus 1. और यहाँ पे one more point what we have noted is this value. Are you getting my point? The sampling both side by an interval, the n should be greater than or equals to l plus m minus 1. So it is like again the what the value of n we are considering, मतलब जो total length हमें expected है. So I have calculated for 3. So is that answer is matching with our question? Like what we have calculated first one? No, right? मैच हो रहा है क्या अपना 3 पॉइंट के लिए?
नहीं सर.
नहीं हो रहा है क्योंकि वहां पे अलाइजिंग प्रॉब्लम आ रहा है आपका. सो उसके लिए आपका रिजल्ट गलत आ रहा है वहां पे. सो डिस्टॉर्टेड रिजल्ट यू आर गेटिंग व्हेन यू कंसीडर द वैल्यू ऑफ n इज ग्रेटर देन और इक्वल्स टू द टोटल लेंथ व्हाट वी आर एक्सपेक्टिंग. तब जाके आपका प्रॉपर वैल्यू आ रहा है वहां पे, राइट? If n equals to 5 I am taking, then what the answer I am getting is, I am getting the answer same as the first answer what we have calculated, but we are getting the 1 point extra as a 0, right? Which doesn't carry any meaning over their part. ठीक है? Understood?
Yes sir.
So why we have to choose the value of n should be greater than or equals to that L plus m minus 1 is, so to get the without aliased result again. So that is how we can use a DFT for performing this linear filtering. So this is all about how DFT can be used as a linear filtering. So I think I need to stop it here, as still we have another 1 or 2 minutes time. If you have any questions, you can ask me the questions. Then further part I will take it tomorrow again or in the next lecture. Any questions? If you have, you can ask me, please. किसी को अगर कोई क्वेश्चन है तो यू कैन आस्क मी. क्वेश्चन है क्या किसी को?
No
हाय
sir.
हाय बोले तो हाय बोलो, नहीं है तो नो सर. सिंपल वे. हाँ, राइट. कैन वी क्लोज द सेशन देन फॉर टुडे?
Yes sir.
Okay, thank you. We'll close the session. You please mark your attendance.
सर.
Yes, madam.
सर,
बोला कि
मेरा नंबर नहीं टाइप हो रहा.
क्या नंबर है?
10 रोल नंबर 10.
10. क्यों, क्या प्रॉब्लम आ रहा है?
10.
प्रॉब्लम आ रहा है क्या?
सर फेल फेल होता रहा है.
ठीक है, ठीक है. कंसिडर दैट, नो प्रॉब्लम. रोल नंबर 10 ना?
ओके सर.
ठीक है.
हाँ सर.
और किसी का कुछ प्रॉब्लम?
Sir, 838.
हाँ, 38 का प्रॉब्लम है. ओके.
Yes, sir.
ठीक है.